Hello everyone, I'm Harish, studying mechanical engineering in National Institute of Technology, Karnataka.
And hello everyone, I am Anita Tiwari, studying mechanical in NIT Karnataka. So here we'll be presenting our project, that is numerical analysis of brake test. So uh, moving on to our problem statement. So our aim is to develop an optimized brake design that enhances the vehicle performance and fuel efficiency and the braking efficiency. So first, we started off with designing our brake disc. So we designed our brake disc by using the standard dimensions that were available online. And after that, we designed it in Fusion 360. After it, the material we used for our analysis was gray cast iron, which is used mainly in the industries. And these are the properties of it. So moving on. Yeah. So for our first we started with uh, thermal analysis. So for that we decided to mesh it with the meshing method as multi-zone, and we also checked the mesh matrices which were pretty satisfactory, as you can see here. So yeah. So these are the input parameters what we got from few websites. So these are the things which we'll be using for our analysis. These are the boundary conditions that we'll be using for our thermal analysis. Yeah. So this is the boundary conditions we gave. That is the convection we gave on this area, and we chose this because this area will be exposed to the air for convection, and so the result we got was the maximum temperature will be attained by this surface, as this surface will be in contact with the brake pads, and the temperature it will reach was around 957.8 degrees Celsius, and it is less than the melting point of the gray cast iron. So means this designs work in this aspect. So yeah, moving on, next we went for stress analysis. So for getting the boundary conditions, we use something called uniform pressure theory that says that when the brake pads are in contact with the brake disc, the brake pads will apply uniform force on the brake disc area, outer brake disc area. That is called uniform pressure theory. By that, we got the torque as mentioned. And then we got maximum brake pressure line as 800 psi that we got from a website. We also referred the name of it. That is called a Brakepedia. And after that, the angular velocity which we choose was 190 radian per second. This is the maximum velocity that a vehicle can attain. So with these boundary conditions, the results which we got was as follows. So the maximum stress we got was 60.394 MPa, and the FOS we got for our stress analysis were 2.94. So the FOS which is required is around 2. So it is more than that. So means our brake disc is pretty satisfactory in this case as well. So yeah, moving on to the optimization.
So coming to optimization with our baseline design, moving on to optimization, we came across different parameter, different mass reduction, and everything. So we'll be seeing one by one. So this was our first optimization where 80% mass is retained, that is 20% is getting reduced in this case. And next we'll go ahead with optimization to design, that is 70% mass retained in this case. And we that designs could not be manufactured and analyzed easily. So we redesigned it in Fusion 360 to analyze it properly. And those designs were not pretty satisfactory in terms of FOS, in terms of thermal analysis, and in terms of manufacturing. And again, we came back to optimization part where we did our optimization again and came with this design. So this is our final optimized design. This will be again redesigned in Fusion 360, and this this is how it came when we redesigned it. First option was this one, uh, where we where we gave just four slots instead of one big gap. And again here we gave small slots for the gaps. analyzing it, this was the best optimized disk we got, and we'll be doing stress analysis where the first design was pretty unsatisfactory. As you can see, the displacement of each node is very big, and the stress is 85, which is way more bigger than the break disk baseline disk. Now, so we rejected our this design here itself, and we are going ahead with this design where the induced maximum stress is just 45 MPa, which is way more lesser than what we got in our baseline design. And this is our thermal analysis where the maximum temperature is 733, which is way more, it's like 200 Kelvin lesser than what we got in our baseline design. And moving ahead with the FOS, the maximum FOS we got is 15, and the minimum is 3.9, which is also way more bigger than the baseline design. The baseline design had just 2.9, and now here we have 3.9. So we stopped our optimization here, and we found the best design, which is better than the baseline, as well as it has more FOS, and it is more thermal efficient than the previously made baseline design. So yeah, we have manufactured this brake disc for our real life testing, and it costed around 16,000, and method of manufacturing was CNC. So here comes the outcomes and results of the project. The mass reduction was 23.25 after optimizing it in Fusion 360, that is redesigning it for our own manufacturing process, and increased the FOS by 34%, that is increased to 3.92, and we reduced the highest temperature uh, attained by the brake disc also. So that was less in baseline design, it was around 340, and here with our optimized one, it is around 740. So yeah, these are the outcomes and results of our project. And further goals will be experimenting the brake disc that we manufacture in real lifetime. And yeah, that's it. Thank you. Thank you.
Thank you.